Hello everyone and welcome to Instant Biology by Dr. Neelab. I am here with you again with another exciting video on bioprocess engineering related PYQs. Now this would be session number 3. Yesterday only I had completed the second bioprocess engineering session on a numerical knockout series, and I got a very overwhelming response in which students were requesting to hold one more session on bioprocess engineering, in which I should take different other sets of problems that are very commonly asked in bioprocess engineering section of GATE biotechnology examination. So in today's lecture, in today's session, I would be dealing with certain problems that are pretty common in GATE biotechnology examination, and we would be dealing with some stoichiometric related questions. Apart from that, we would also be dealing with some delta G related questions, that means free energy related questions. You would be knowing that thermodynamics is an important aspect of your bioprocess engineering section, unit number 4, unit number 5. So we would be dealing with that as well. So stay tuned. In this particular lecture, I would be showing you that how you can solve different sets of problems with ease, with some tricks, with some formulas. Please note down these formulas and practice questions like these, because I'm hopeful that questions like these would be asked in your GATE biotechnology examination. Apart from that, those who have not seen the past bioprocess engineering related sessions, session number 1 and session number 2, I would suggest you to please watch those sessions. They have extremely important problems that I have discussed, and those will be definitely useful for you to secure good marks in your GATE BT upcoming examination. So without much ado, let us start today's session. Again, this is session number 3. I would request you to watch the previous sessions before you start watching this session number 3. So let us start. Firstly, the first question that would appear on your screen would be: Saccharomyces cerevisiae produces ethanol by fermentation. The theoretical yield of ethanol from 2.5 gram of glucose is. Now this is a very simple question, but I have seen that many students, they are not able to solve the simple questions also of bioprocess engineering because they do not have clear basic concepts of your bioprocess engineering. Now see, it's not always that the typical most difficult questions are asked in bioprocess engineering. This is a fairly simple question, and even if you are not aware about the typical things of bioprocess, if you understand the simple aspect of bioprocess, then also you should be able to solve questions like these. Now what is it saying? Let us break it down and let us do it step by step. So Saccharomyces cerevisiae, now you would be knowing that this is a yeast and it produces ethanol by fermentation. The theoretical yield of ethanol from 2.5 gram of glucose. Now one important thing that is necessary when you solve questions like this is you should be knowing the equation. Now you can see that equation in this question has not been given, but this is a fairly simple problem in which you should be knowing about the fermentation equation that is used by Saccharomyces cerevisiae. Let me just write it down for you. So as in the question, it is mentioned that glucose is being used, if you provide glucose to Saccharomyces cerevisiae, it will yield ethanol. So that is what we are doing over here. So C6H12O6, this would be giving off 2C2H5OH plus 2CO2. This is the general equation that you should be aware about. Now this is glucose, as you should be knowing. Obviously Saccharomyces cerevisiae uses glucose and it produces product, and the product over here is ethanol. Now it is asking what is the theoretical yield of ethanol, how much yield of ethanol would be produced, what would be the yield of ethanol. Now let us solve this. First of all, you should be aware about the concept of moles if you want to solve questions like these. Not always, as I said, not always you would be requiring typical formulas and big formulas. No, it's not necessary always. This question can be solved by mole concept simply. Now over here you can see that this is 1 mole. That means 1 mole of glucose is forming 2 moles of ethanol. 1 mole of glucose is forming 2 moles of ethanol. Now, if you want to know what is the molecular weight of glucose that is present over here, so we can calculate the molecular weight over here. Let me just quickly calculate the molecular weight. Obviously all of you would be knowing, most of you would be knowing, but for those of you who are not aware how we can calculate it, I'm just doing it for you. C6H12O6. Now for carbon it is 12, so 12 into 6, plus for hydrogen it is 1 plus 12, and 16 into 6, that means it would be 96. So if you add up this will be coming out to be 180. So 96 plus 20, it would be coming out to be 180. So this is the molecular weight for glucose. This is molecular weight for glucose. Similarly, I should be knowing the molecular weight of ethanol also, C2H5OH. Now for ethanol, the molecular weight is 12 into 2 plus 5 plus 16 plus 1. So 24 plus 5, 29, 30 and 46. So this is 46. And you should be knowing that the molecular weight, or basically 1 mole, is equivalent to the molecular weight of the compound that you are looking at. So this would be yielding out to be 180 gram, is actually giving you that 2 moles. So 2 into 46, I can write it down like this, 2 into 46. So 180 gram is yielding 2 into 46 gram of ethanol. So how much glucose are we talking about over here? 2.5 gram. So you can calculate for 1 gram of glucose how much ethanol can be formed. So 2 into 46 divided by, it can be 180. Just one thing, I'm just going to check if you are able to view whatever I have written. Yes. So this and so 2 into 46 divided by 180, and now you can calculate for the 2.5 grams. So 2.5, 2 into 46 upon 180 into 2.5. if you solve this, and you would be getting 1.27 gram, 1.27 gram. Now I believe you would have seen that theoretical yield, by theoretical yield we simply mean that what is the amount of ethanol that you can form from the glucose. Now simply, if you are aware about this equation, then you would be able to solve this. And this equation is not a fancy equation, it's just that we are talking about fermentation. In fermentation, oxygen is not used, so that is why we are not using oxygen over here, and strictly glucose is getting converted into ethanol and carbon dioxide. So this was the first question I wanted to show you. Now let us move on to the next question. The binding free energy of a ligand to its receptor protein is, let me just highlight it. The binding free energy we are talking about over here of a ligand to its receptor protein is minus 11.5 kilojoule per mole at 300 Kelvin. What is the value of the equilibrium binding constant? R value, or the gas constant value, has been given to you. In yesterday's class also I told you that the R value you should be remembering. If it is not given in the question, then also you should be in a situation to use the R value. Now one more important thing is, in your bioprocess engineering section, there is a topic called as ligand and protein, or ligand receptor ligand interaction. Basically, from that portion, one such question on scattered plot has already been asked. This is another question that is asked from that same topic, but however this is a numerical question. In that problem, that was a purely graphical question. on scattered plot. So let me just quickly make you understand that. Let me just draw this diagram. So let us say that this is a protein, or let us say this is the enzyme, and the ligand is binding over here. Let us say that the ligand is binding like this. Ligand is binding like this is the ligand, okay, and this was your protein, or whatever you can call it, okay, or receptor, you can call it as a receptor. So the binding free energy, see, they are mentioning that it is a free energy. Now obviously free energy can be used to do work. Now you should be knowing that free energy can be converted. There is a simple formula for free energy. Delta G is equals to minus RT ln K equilibrium. This is the formula for delta G. Now in this, delta G value has been given over here. Let me just quickly write it down. Delta G is equals to minus 11.5 kilojoule per mole, and temperature has been given to us. It is 300 Kelvin, so we do not need to convert it into anything. Generally, please check out the temperature in general cases is given in degree centigrade. You can add 273 degrees and convert it into Kelvin, so then you can then use the degree Kelvin temperature. So temperature over here is 300 Kelvin. What is the value of the equilibrium binding constant? Now they are talking about the constant K equilibrium they are talking about. So K equilibrium we are not aware, and additionally R value has been given over here, 8.314 joule per mole per Kelvin. So this value has also been given to us. Now strictly we have to calculate delta G value over here. We have to calculate the K equilibrium value over here. Delta G has been given. It is minus 11.5. So it is given in kilojoule. Obviously you cannot use the kilojoule value, you will have to convert it into joule. So I just multiply it by 10 to the power 3, and this would be equal to minus R, that means 8.314 into temperature is 300 ln. I do not want ln, I can convert it into log. In yesterday's session also I told you how you can convert the ln value into log value. Just multiply it by 2.303 and write log over here, and then you can mention K equilibrium. So I can quickly solve it now. 11.5 into 10 raised to the power 3 divided by, divided, this minus sign can be cancelled out. I can just simply cancel it out. So I'm just removing the minus sign. 11.5 into 10 raised to the power 3 upon 8.314 into 300 into 2.303. So the value that I am getting over here, this will be equal to log K equilibrium. Now the LHS value, if you solve the entire thing on the left hand side, you would be getting 2. So 2 is equals to log K equilibrium. Now obviously you'll have to take the antilog value. Antilog of 2 is equals to K equilibrium. Therefore K equilibrium would be equal to 10 to the power 2 or 100. Okay, so this would be the form, this would be the value for K equilibrium. I believe you would have understood this question. So this is again a ligand receptor interaction question. Now let us move on to the next question. Before moving on to the next question, I have a very important announcement to make. I had told you about this in yesterday's session also. So we are starting a GAT B session or GAT B crash course. So GAT B is also around the corner for those of you who are aiming at getting getting an admission in MSc courses or MTech courses. GAT B is a very important examination, and we are starting a special crash course for GAT B, and it is going to start from 28th of February. And a lot of things, a lot of benefits are included in that session. We are going to give you the PDFs for your lifetime, Apart from that, the recording sessions would also be available. Live classes will be taken and recorded sessions would also be available. Recordings would be available till the examination. You can watch as many times as you want. There is no restriction in that. And you can download the PDFs. The test series is included. After completing the entire material, we would be also doing the revision with you, in which we would be solving the PYQs so that you can get a better grip on the examination. And all of this and much more you would be getting for 3500 rupees only. So these are the charges I've mentioned over here. You can just check it out. These are the charges of the course. Apart from that, after the GATB examination, we would also be guiding our students for getting entry into the colleges, which colleges they should choose, what they should be doing, things like that. So if you are interested, you can get in touch with us. The contact number, I'm just going to write it down over here. This is the contact detail: 8299134528. 8299134528. This is the WhatsApp number. You can connect with us on this WhatsApp. Apart from that, the email ID has also been mentioned in the description section of this video. You can connect with us through email also, or you can also join our Telegram group and connect with us on the Telegram also. So again, there are only 30 seats. I would want to tell you, only 30 students would be taken in. You would be knowing that my sessions are very small in size. They are not humongous in size, so that we can deal, or we can understand, or we can look at each and every individual that is present in the batch. So this is on the first come first serve basis. If you are interested, kindly connect as soon as possible. There are a few seats left only. Now let us come back to our original discussion, in which we were discussing about the bioprocess engineering problems. Now I am specifically telling you time and again that decimal reduction time problems have been asked innumerable times, and in each of my sessions, session number 1, 2, and this is session number 3, in all these sessions I have shown you that there are problems related to decimal reduction time. In today's lecture also I'm showing you this. Okay, so decimal reduction time, again let me just quickly tell you the formula for decimal reduction time. Decimal reduction time, or D value, is equals to, now I believe all of you would be remembering the formula. It is simply 2.303 upon K. Now what is this K? K is the thermal death rate constant. Let me just quickly write it down over here. Thermal death rate constant. So this is the value for K. And what is given in the question? So decimal reduction time of a microbe during sterilization at 120 degrees centigrade with a first order thermal death rate constant. Now remember, this is the first order reaction. Obviously whenever you are sterilizing, or whenever you are creating situations in which the microorganism would be dying, they would be following the first order reaction kinetics. Always remember that. So this is 1 per minute, and they are asking you what should be the the decimal reduction time of a microbe during sterilization at 120 degrees centigrade with the first order thermal death rate constant of 1 per minute. So K value they have given as, K value has been given as 1 per minute, and they are asking you decimal reduction time. So simply 2.303 upon 1, so this would be coming out to be 2.3. This is the decimal reduction time. So if you are getting these type of questions, you should feel fortunate enough, because these are extremely simple questions and they come under NAT, and you would be getting some good marks if you are able to solve questions like these. Now let us move on to the next question. The free energy change of ATP hydrolysis is 25 degrees centigrade. The free energy change, let me just quickly mark down the important points. The free energy change of ATP hydrolysis at 25 degrees centigrade is minus 32.2 kilojoule per mole. Now what do you mean by ATP hydrolysis? By ATP hydrolysis, I simply mean that ATP is breaking down into ADP plus PI. Now they are giving the free energy change, or the delta G change, is equals to minus 32.2 kilojoule per mole. Now I would want to point out one more thing over here. Delta G questions are asked a lot of times. Now you should be able to understand when is the, or what is the meaning, or what does it imply when delta G value is negative, what does it mean when delta G value is positive, or what does it mean when it is zero. You should have a very good idea about that. Apart from that, when is the reaction spontaneous, when is the when is the reaction non-spontaneous, or when is the reaction at equilibrium. Apart from that, there are other aspects that also that you should look at when talking about delta G. So very important, again, delta G concept. I'm going to show you one question like this. I'll be solving it. Now the free energy change for hydrolysis. The free energy change for ATP hydrolysis has been given. Now the free energy change of hydrolysis of alpha glycerophosphate to glycerol is minus 8.2 kilojoule per mole. Now that means alpha glycerophosphate, it is getting hydrolyzed. That means when it is getting hydrolyzed, that means phosphate group is getting removed and it is normally getting converted into glycerol. So you can see that phosphate group was present over here. Because of the hydrolysis, phosphate group got removed and we are ending up in glycerol. Now the delta G value for this reaction is equals to minus 8.2 kilojoule per mole. Now using the above information, the free energy change for the formation of, now you can see that what are they asking? Formation of alpha glycerophosphate from glycerol and ATP. Now what does this mean? It is simply implying that I have to form from glycerol plus ATP, we have to produce alpha glycerophosphate. Let me just check if I'm not hiding anything. Yeah, plus this should be the ideal scenario. Now we just have to add the two delta G values, but important point over here is that the first, in this reaction there are two things that are happening. So this is the main reaction that we have to look at. Okay, so glycerol is getting converted into, let me just use different pens. Glycerol is getting converted into alpha glycerophosphate. Is the delta G value given to us for this particular reaction? No, actually in this reaction you can see that alpha glycerophosphate is getting converted into glycerol. That means it is the reverse reaction that has been given to us. The reaction, the delta G value that has been given to us is for the reverse reaction. In this, alpha glycerophosphate is getting converted into glycerol, but ideally what I want is glycerol getting converted into alpha glycerophosphate. That means phosphorylation reaction. So now you should be knowing that delta G reaction or delta G value for the forward reaction and for the backward reaction, the measure or the value remains the same, only the sign changes. So over here, if I am reversing the reaction, the delta G 8.2 value will remain the same. It will just be plus 8.2. Okay, now obviously you can see that ATP is getting converted into ADP plus PI. This is ideal for us. This is what we wanted. And the delta G value over here is given to us as minus 32.2 kilojoule per mole. This is what is given to us. Now obviously, since this reaction is occurring as a whole, I'll have to add up the two delta G values. So total delta G total should be equal to minus 32.2 plus 8.2, and this would be coming out to be around minus 24 kilojoule per mole. So this is the formula, or this is the thing that would be happening, or this would be the answer. Okay, so I believe you would have got a clear understanding about this question also. Again, I'm saying again and again that questions related to delta G are asked many a times. You should be very focused on that and remember the concept. Moving on to the next question, and this would be the final question of our bioprocess engineering sections. So no, I'm sorry, this is the third question, I believe. Just a minute. So first, second, third, fourth and fifth, yeah, this would be the final question, sorry. So an evaporator is insulated using glass wool material of 0.15 meter thickness. Now this is an interesting question, and it is just the or let me just first of all go through the question, and then I'll be marking important aspects, and then I'll be telling you how this can be done. An evaporator is insulated using glass wool material. Now you should be knowing that glass wool is a very commonly used insulator, and the thickness of the material is 0.5 meters. The innermost surface and the outermost surface of the insulator are 700 degrees centigrade and 80 degrees centigrade respectively. Okay, the mean thermal conductivity, that means the question that is asked over here is on conductivity, that is the heat transfer. Now again, conductivity and convection, conduction and convection are the two ways that are in your course that you should be aware about. Generally in convection, the individual heat transfer coefficient questions are asked, or delta U questions, related questions are overall heat transfer coefficient questions are asked. You should be knowing about that, but generally conduction questions are not that very commonly asked. That is why I have taken this question over here, so that I can explain it to you how you can do this. So the mean thermal conductivity of the glass wool under these conditions is 0.29, and the rate of heat transfer area is given as 1.2 meters square. Let me quickly write down what is given. So the thickness value D is equals to 0.5 meter. This is the thickness. The temperature, outer temperature is equals to 80 degree, inner temperature is equals to 700 degree. Okay, now again you'll have to, this is let us say this is T2, this is T1. Obviously I'll have to find out the gradient, or find out the difference in the temperature of the inner and the outer. So delta T would be equal to 700 minus 80, and this would be coming out to be 620, I believe. Yeah, 620. Now obviously understand this, that I'm not converting into degree Kelvin over here, because I want to find out the difference. If you convert it into degree Kelvin, then also the difference would be the same. Ideally I should convert it into degree Kelvin, but again the difference would be the same. We have to find out the difference over here. So 620 would be the difference. So outer temperature and inner temperature I have found out, and the thermal conductivity value, that means the K value, this is a constant, it is given as 0.29. Yeah, so there is a formula of the conductivity, basically the heat transfer through conduction. So I'm just writing down the formula for this. So Ka, so the heat that is transferred through the conduction, Q is equals to K into A into delta T upon D. So I'm just putting the values now. So K is equals to 0.29 into A value is equals to 1.2 into delta T value is equals to 620 divided by D value is equals to 0.15. Now if I'm solving this, what I'm getting is, it is 1438.4 value, 1438.4. so this would be the heat loss in watt. Okay, this would be the final value, 1438.4 would be getting. So these questions are of different sort. These questions have also been asked. In today's lecture I was focusing upon thermal conductivity, decimal reduction time. Apart from that, I have also taken certain questions on the thermodynamics delta G concept. So I would request you to practice all these questions. There are high chances that they would be asked. So I believe you would have liked the session, and do tell in the comment section what you would want more. This is the last session on bioprocess engineering, because obviously we do not have much more time left, and I would ask you guys to revise more and more. One more important thing is I would request you to check out the 1 minute ki Qeemat session. They are only 1 minute long, and definitely you would get a lot of insight on different questions that are asked. So thank you so much and all the best. Have a good day.